Okay, this one's different. I'm going to try to do what I just did, same approach. Take this item and try to pull it apart and see what happens. Well, if I pull it apart, I get A times something plus B times something, but because the 7 is sitting here, I have this extra vector. I need to have this extra vector dangling off the end. So that does not smell good. That seems like it's not going to work. So what do? Well, I have a feeling it's not going to work because I'm trying to write H as the span of some vectors. But here I see that you just can't do it, right? You cannot. H does not equal. H does not equal the span of 110 and 101. Okay, it does not. Because, well, the 0 vector is in here. And is the 0 vector in here? Is the 0 vector in here? Said otherwise, does the 0 vector equal one of these guys? And the answer is no. So here I am thinking out loud, 0 vector in H. Well, I'll try. I'll try to write the 0 vector as one of these guys. Well, I'll put it back together just to make things a little bit easier. So is the 0 vector one of these guys? These guys here. So can I find A and B? Do these numbers A and B exist that will make this equation here true? I don't think so, but let's see why. A plus B is equal would need to be 0. A plus B would need to be 0. A plus 7 would need to be 0. B would need to be 0. Now, if B is 0, what does that tell me? Well, it tells me that A has to be 0 too. Which tells me that 7 is 0. No such luck. Okay, what you're doing here is you're assuming that A and B exists, and you're following the logic. And your logic leads you to an obvious absurdity. So your assumption that A and B actually exists that will make this work, that assumption is false. Therefore, A and B do not exist. Therefore, the 0 vector is not in H. And therefore, H is not a subspace of R2, R3, not a subspace of R3. Okay, one more time from the top. This 7 here was bothering me. Okay, it's just 7 all by itself here. It's different than my preceding examples. Okay, writing this out tells me that H is not going to equal the span. In more detail, more specifically, the zero vector is not going to be in H. Okay, and how do I show that? Well, I say, okay, let's try to make the zero vector equal something that's in H. And I see that that leads to a contradiction. Okay, so assuming that the zero vector is in H gives me this contradiction. So my assumption that the zero vector is in H must be false. So zero vector is not in H, and that means that H is not a subspace of R3.